Hello, in this Excel tutorial video for Chem 1B, we'll be looking at the next part of data workup for experiment 7, in this case the titration of a weak acid with a strong base. I'm still using the same spreadsheet that I've used before. It has my other calculations in it, but now I've moved on to my weak acid data titration with a strong base. This isn't that different from what you would do with the weak base titration with a strong acid. Basic setup's going to be the same. I'm going to insert some rows so I have some space to work at the top. Enter my name, my lab section. I'm going to be doing a pH calculated again, so I'll relabel this as pH measured. I'm going to make my D column narrow just as a little spacer, and I'm going to be calculating some other columns to simplify the calculation that shows up in that column C. So I'll do millimoles of titrant again, and I'll do volume total. I'll want a millimole of HA in this case and a millimole of A minus. And the reason why is when we're doing the weak acid titration, we're going to end up with a buffer situation in the middle. And I can use the buffer equation, the Henderson-Hasselbalch equation, in that region. I'm going to need these two values for that. When I get to the end of the titration, the last region is going to be excess hydroxide. So I'll need a millimole. Actually, I'm going to do a concentration of OH. And then the last column I'll do is a concentration of acid. The constants I'm going to need for this is, again, the concentration of acid, the volume of acid, concentration of base. I'll need Kw again, but I'm also going to need the pKa of my weak acid and the Ka. Okay. Concentration of acid, I get off that standardization titration tab. The volume of acid I should have in my experimental notes. In this case it was 20.2. Concentration of base, click equals, click on the new tab, select the cell, enter. Kw I type in 1 times 10 to the minus 14. The pKa for acetic acid is 4.76. And the Ka, I could type it in from a literature value, or I can just calculate it from the pKa. In this case is equal to 10 to the power is that caret key over the number 6, shift 6, caret minus pKa. And that gives me my Ka value. And those are the constants I'm going to need to do these calculations. I'm going to calculate my millimoles of titrant in the same way I did last time. It's equal to the volume of base added times the concentration of base. And I want to make that concentration an absolute cell reference by hitting F4. Total volume is equal to the volume of base added plus the initial volume of acid. And that initial volume of acid should be an absolute cell reference. The millimoles of the weak acid is equal to the millimoles I added, which is the concentration times the volume. Both of those as absolute cell references. But the next step in my ICE table is that change. And that change is consumption by the volume or the amount of titrant I've added. So there's my minus X. Okay. Likewise, in that ICE table, the millimoles of A is that change. It's that amount of titrant that I've added that's converted it to A. Now, initially, in this first data point, I don't have any of the conjugate acid, so this isn't a buffer problem. This is a weak acid problem. And I can calculate the hydrogen ions in the weak acid. I'm solving that weak acid dissociation problem, which is going to be approximately the square root of the acid dissociation constant times the formula concentration. Okay. And work that out by hand to make sure you know how to do that problem. That's a favorite for us faculty types to stick on quizzes. Okay, and that gives me a hydrogen ion concentration. I can calculate the pH from that as minus logarithm of that hydrogen ion concentration. Now I'm going to enter a little label over here just for convenience that this is a weak acid problem. Okay. Now as soon as I take these cells here and drag them down one, now I have a mixture of an acid and its conjugate base, and it's a buffer problem. In the buffer problem, I don't need to worry about calculating hydroxide or hydrogen ion. I'm going to use that Henderson-Hasselbalch equation directly, and the pH is equal to the pKa, it's going to be an absolute cell reference, plus log of the base over the acid. Now because these are both in the same container, the mole ratio is equal to the ratio of concentration, so I can simplify my calculations here a fair amount. Okay, and then enter. And I'm going to go ahead and copy this down until it gives me an error. And it's going to give me an error right about the time that that concentration of weak acid, the HA, goes negative. Okay, and I'm just going to delete these cells here. What I need to do at this stage is actually these can keep going, but now I've gone into a stage where I have excess hydroxide added. And that excess hydroxide is the moles of hydroxide, and that's the moles added, minus what was consumed by the weak acid. Now I've completely consumed all the weak acid, I have excess hydroxide, and the amount consumed by the weak acid was the concentration of acid times the volume, and that's going to give me my millimoles. Okay, I'm going to make those absolute cell references, and there is my hydroxide ion, excess hydroxide ion millimoles. To get that to concentration, I'm going to take that whole value, the number of millimoles, and I'm going to divide by the total volume. Okay, and there's the concentration of excess hydroxide. The concentration of hydrogen ion is Kw divided by that concentration of hydroxide. So I've put an absolute cell reference on my Kw, and my hydrogen ion concentration at this stage is 6.6 times 10 to the minus 12. I can get the pH is equal to minus logarithm of that value. Now in this case, the student collecting this data skipped right over the endpoint of this titration, and there's a big jump in the measured values. If the student had managed to get a data point very close to the equivalence point of the titration, you would do a weak base problem, but this is a strong base problem at this stage. Getting a data point right at that sharp transition can be quite difficult, and so it's understandable that they've missed it. Hopefully you got it, and you'll do a simple weak base calculation for a single data point there at your equivalence point. But now I'm to this stage where I'm in strong base, and it's going to be the same till the end of the titration. And I'm just going to copy it down by selecting all the cells I want to copy, grabbing the handle, and dragging down. Let's go ahead and plot this data, see what we got. I'm going to select the data I want to display, Chart Wizard, XY scatter, don't use the smoothed curves. That looks like my right data series. My chart title would be weak acid titration. My X is volume titrant in milliliters. My y-axis is pH. I don't want grid lines or a legend. Okay. Oops, I entered it so it went in the sheet. I want to make it a new tab. I can right-click on the chart, click Location, New Sheet, and I'm going to do my weak acid strong base plot. Okay, so there's my plot. It's on a nice separate page. I can select that gray area and delete it. I want to take this and change my data so that it is markers and not a line. And there's my fit. You can see it's fitting very nicely through this buffer region, but not so well up here at the top end. This is likely because my hydroxide ion concentration is off. If you have any questions on how to do this, talk to your instructor. But at this stage, you should know how to do the calculations for a weak acid, weak base titration. weak acid strong base titration.